Let's discuss Carlson Software Machine Control Division's new hardware components and how they play a role in solving positioning and 3D machine control application challenges. Now, the goal of positioning, there are several goals in positioning machines. One is to georeference, usually in 3D, the machine on the Earth. And once we've got a position, and of course the application will determine the accuracy of this position, we then need possibly to measure the articulation of the machine. For example, if I'm looking at just a base position of an excavator or a shovel, once I have that position, I'm going to want to know the heading and also possibly measure the articulation of the boomstick bucket or whatever other movement and articulation that is applicable to whatever application is being used. And then once I know those points of reference, I'm going to want to intersect one or more of those positions with a digital terrain model. From that, we can do lots of things like build avoidance zones into the DTM and reference that to the machine. For example, if an excavator is lifting its boom up in the air, we want to make sure maybe we have a conveyor system up above that we don't want to hit, or maybe there is a high wall and a mine that we don't want the machine, of course, to go over. So we can build avoidance zone logic once we have this accomplished. And then some of the bigger picture items are that we're able to store data, stream data locally or back to the office, or store data locally, and then be able to produce real-time or post-analysis reporting, production, and even do historical playback of the actual machine. So these are the key components that we're currently using to solve some of these positioning challenges. First, we have the new Carlson CBX5 control box console. This is a Carlson exclusive. It has Windows 7. It has a industry standard Intel 1.6 gigahertz Atom processor, a gigabyte of RAM, and a 16 gig solid state drive. The screen is 10.4 inches and very bright in the sun with an active touch screen. There are 2 CAN bus ports, 2 serial ports, and 2 USB ports. There's also an Ethernet port and a GSM SIM card support. This is important for, well, you can even stream in trip RTK correction through the SIM card, or perhaps or more importantly, be able to perform remote monitoring, software and firmware upgrades. The unit is very special to us, and one of the things that make it special is the fact that it has an industry-exclusive 3-year warranty on the box. The other item that makes the box pretty special is that it has an integrated GNSS receiver board. It is GPS plus GLONASS L1, L2. It comes with an update rate of 10 Hertz, upgradable to 20 Hertz. And you can bring the RTK correction through the SIM card that we just talked about, or through an external UHF or 900 megahertz radio. Another possibility would be a data radio or mesh radio via the Ethernet port. Now, the box comes with the receiver already installed, and it's priced without the receiver activated, but a code can easily activate the receiver, and the Carlson application software can then utilize that for positioning. So for some applications, this is quite a nice, compact solution. I simply can install the control box, give it power, enable the internal RTK receiver board by whatever Carlson machine control application we're using, and then add an antenna, cable, and GNSS antenna. The other key component that's new that we think is quite special is the new Carlson MC Pro VX5 all-in-one sensor. Now, this has a baseline between antennas at 50 centimeters. So this is an L1, L2 GPS plus GLONASS RTK receiver that has position and heading. There is also an integrated RTK UHF radio for our RTK corrections. Now this is eliminating an external radio cable, external radio cable antenna for the radio, and the radio antenna itself. There is also a pitch and roll sensor built into this unit. So I can take the unit for, depending on the application, let's say it's a mining dozer or a landfill compactor, and I can put this unit on the roof of the machine, and I get all of the sensing that is required for some of those applications, and only one cable back to the CBX5 control box console. This too has an industry exclusive 3-year warranty. The unit is IP69K with a very broad operating temperature. So in summary, inside the single sensor we have 2 GNSS receivers and 2 GNSS antennas. We have the RTK radio plus the antenna and a pitch and roll sensor. For heading only applications, we do have the MC Pro VX1, which is heading only. It does not have RTK radio and unable of RTK correction, but this is more affordable. It takes exactly the same connector and cable as the VX5 and exactly the same form factor and mounting hardware. Another item that we use is the SNX5 axial and angular sensor. This unit is a single unit that can be configured for pitch and roll or angularity. So we can use this on a dozer, for example, or enable the angularity and use this on a boom, stick, and bucket for angularity, like on an excavator, dredging application, or a shovel for a mining application. It's very rugged. It's rated at 30 bars or 30 meters submerged in salt water. We have clients and partners that are using this in very extreme conditions in dredging applications. The update rate, the angularity, pitch and roll, all of these items are software configurable. So we don't have to violate or open up the unit in the field. It also is able to emulate some other sensors. So if you're using a particular brand of sensor, there is a possibility that we can remove that sensor, put this sensor on, calibrate, and continue working, because to use multiple brands of sensors in the same CAN bus line, we need the protocol and communication to be the same. So this is possible, but we would need to check, on a per case basis. This is a smart antenna, or BRX5 GNSS smart antenna, and it's a very affordable, durable GPS plus GLONASS L1, L2 GNSS receiver. It can contain a 900 megahertz or UHF radio, and there's also an internal SIM card for remote communication, and that may be the unit has been stolen or knocked over, or we may need to go in and verify the unit, change a setting, upgrade firmware. All of these are possible with the SIM card slot. For pure machine control applications, we also have a new receiver and radio configuration that allows us to put a single point positioning, RTK positioning. Perhaps I'm not going to use the internal GNSS receiver board in the CBX5. Maybe I'm not going to use the VX5 RTK all-in-one sensor, and I just need an affordable RTK only position. The RX5 provides that. I have an RDX5 radio, and then I have the antenna, and this provides simple RTK position, and the radio RDX5 is available in UHF or 900 megahertz. I can also add 2 of these to get heading for a larger machine where I need a wider baseline. We have the grade supervisor system, and this is quite a powerful site management tool, certainly for machine control applications, because it's basically the machine control software on a stick. So I can use the smart antenna with our tablet, with Grade Supervisor. I have the same user interface, the same data files. It can communicate with all the machines. I can do volumes, coordinate geometry, build slopes, collect stake and as-built points. It's a very powerful entry point for machine control, and it allows a site manager to provide strong support for multiple machines. The software also contains our GNSS library, so it does support most GNSS receivers that are on the market. And speaking of our open positioning architecture GNSS driver library, we support certain models from each of these manufacturers built into our Carlson machine control software. Now, we've taken a look at a lot of the applications, or we've taken a look at the components used to monitor and apply positioning and create a certain anatomy for positioning, but really the applications are what drive this. So let's just take a look at a few of the differences between applications and how we might, what they're doing and how we might apply the components to achieve a machine control system. Solid waste landfills, for example, these are primarily track elevation. They're compacting the waste stream, building slopes. So track elevation is all they need. So we can apply the particular application software that will monitor pass counts, that will allow the operator to manage the slopes. They may need to store points for hazardous material. And of course, there are certain application-centric reports that need to be generated. But again, the solid waste landfill has its own application requirements, and we're able to use the components, create a machine control system for that, have certain user interface features that apply to that application, and then very easily provide a nice solution. In blast drilling, now these are quite flexible machines that have a lot of degree of freedom in motion. And for this application, the operator will want to import a drill pattern from various sources, or perhaps create a drill pattern manually in the field. And our application software, Drill Grade, provides these features. They'll want to navigate to a hole, drill to a surface, and depending on the job site, it may be quite difficult to approach or navigate to the hole. The terrain may be very rough, all rock. And once they navigate to the hole, they'll then need to position the feeder in the particular design angle in order to drill the hole. And they're going to want to know the top of the hole, the bottom of the hole, the depth, the angle, and then be able to mark the hole as it was drilled and in comparison to the design. And all of this data is stored in a DRL file and can be used to generate reports. The hardware, let's talk about a drill. If we're looking at blast drilling, the hardware that we've looked at, here's a very nice, simple wiring diagram to accomplish positioning on a drilling system. So that we're using the VX5, the yellow all-in-one sensor, as a high-performance heading, or use the VX1 for L1 heading, and install the control box, the CBX5. We can see the battery backup and the power, and we can enable the internal GNSS receiver, run the antenna to the top of the feeder, And the antenna shown here is actually the GSM antenna for the SIM card slot. Another configuration might be that we use the serial port to connect to a third-party GPS receiver if a client has already made an investment in another brand of GPS. However, we usually can accommodate our system to be compatible with an existing system, but we're flexible. We can go either way. So this has come a long way in how simple the system can be set up. Now, there's also axial sensors on a drill. There's body, pitch, and roll. There are encoders. There are different positions of the feeder, and we need to monitor and measure those angles as well. And there's two ways to do that. One is to retrofit sensors on the drill and then feed those sensors to one of the CAN bus ports on the CBX5. That we can do. This would be similar to a retrofit, to retrofit a drill. The other method, a good example, is explained through an alliance or partnership with Atlas Copco, in that when they build new drills, all of the sensors are already installed on the drill. So Atlas Copco has a whole navigation system, which is powerful. This is the display for that. It provides lots of features, and for many applications, it's all that a client or operator may need. But what we've done is we've created a partnership where Atlas provides a protocol that has to be enabled, and it can be plugged in via Ethernet from their rig control system into the back of our control box and drill grade software. And we read the sensor protocol across Ethernet as if we had retrofitted sensors. So it's a very clean installation. This can be a factory option when a new drill is ordered and provided brand new with the system already installed. And these are a few of the installation and verification images in Örebro, Sweden at Atlas's factory. Here we can see the heading unit and Atlas Copco verifying and testing a new drill. We talk about application differences and applications driving the anatomy of the positioning system. These are a few screenshots. This is our drill grade software, and it gives you an idea of how 3D drilling and its requirements for importing and laying out drill patterns, monitoring the angles, monitoring penetration, seeing the bits drilling real time, marking holes that have been drilled, being able to see where the bit intersects with the digital terrain model or a particular elevation. This screen shows us different ways of editing the hole and importing files in various formats. Light pile driving. This is a new application that we have addressed recently. And a good example for this are large solar farms. This machine's in the images here, for example, is the Vermeer PD10. It is designed for light pile driving for solar farms. So these folks have large numbers of points or piles to drive typically. It can be from 20,000 and upwards to 1,000,000 points. So they need to be able to load the design, high numbers of points, navigate to the point, which means they really need heading, and they need pitch and roll on the feeder or the mast, and they need to know when they've reached their elevation. So we can add our VX5 all-in-one sensor to the top of the feeder and achieve heading, RTK position, the RTK correction, and pitch and roll as a verification of the pitch and roll that's already built on the machine. So it gives you a check, redundant systems to verify that the machine is plumb when driving the piles. And then the application-centric software can record the as-built points, and it gives a simple user interface for the operator to work from. This is another image showing the anatomy of, here's the control box. This is an open cab system, so the ruggedness and waterproof nature of a control box is real important here. Same with the IP69K rated VX5. This could be also addressed with 2 GNSS receivers, 2 GNSS RTK radios, and 2 antennas. But this, using the VX5, we can basically use 2 components and 2 cables. It's a very simple installation, and it leaves the toolbox in the back open and free of positioning components. Dredging is a very unique application, and it can vary from site to site. There's many custom configurations and multiple attachments. Typically with an excavator, a boom stick bucket is a typical configuration. Dredging may have 2 booms, so it would be body, boom stick, bucket. The buckets can tilt, swivel. The attachments, there are a lot of different attachments, and the software and the hardware need to accommodate these variations. Cable cranes, which mean that there are flow meters and line riders and other encoders used to monitor the articulation of cable cranes and what it is that they're trying to do. Also, many times, for example, in this image, the excavator or dredger is sitting on top of a barge. So it may be important to monitor the barge heading as well as the machine heading on the barge. So lots of intricate details that are required for a dredging application. Again, I'll go through just a few screenshots. I don't want to go into each of the application software. This is more of a hardware discussion and how it's used to address the various applications. But here we can look at the differences from the drill grade. We can look at our dredge rover software and see variations of what's monitored. Here we can see the water line and different, the design surface versus the existing terrain, so that we know where the bucket or whatever we're using, whatever attachment we're using to remove or place material, where it is relative to the existing terrain and the design surface. This is a finger grab, for example. We need to monitor the opening and closing of this. This is a unique attachment that is pulling material in a horizontal fashion. So we need to monitor the way this moves so the operator knows when it's open, when it's shut. And another unique challenge from this type of attachment is that when it picks material up in a harbor, for example, the footprint is different than a bucket. So that means that your surface is being updated in a different manner. And, these folks are paid by volume and by the progress. So it's very important that these variances and these attachments and the way they update the surface and report volumes are calculated. Here we see a dredging bucket, and we can see it providing a cut fill color map on the plan view portion of our interface screen. Surface mining is another application that Carlson Machine Control focuses on heavily. And there are many different types of machines and processes on a mine. There may be dozers and shovels, drag lines, bucket wheel excavators. It may involve blast drilling. So from dozer pushes to material management and haul trucks, to the shovels, to the drag lines. There's lots of different types of machines that require different types of positioning hardware to be applied, and then the application-centric software to handle that machine and its process. So I thought I would take a few of these machines and just illustrate and animate how a control box, GNSS receivers, the all-in-one sensor, the axial sensors, how they might be applied. So here's a shovel similar to an excavator or dredger. Here we see two individual RTK receivers with a wide baseline, because this is a large machine, and the 50 centimeter baseline of the MC Pro VX5 may not be accurate enough. We see the RTK radio, and then we see the body, the boom, the stick, and the bucket axial sensors being applied. All of this being measured, and all the articulation being monitored, fed into Carlson machine control software, and in this case is shovel grade, and then we can monitor the update of the bucket. We can see the accelerometers, axial sensors moved to monitor positioning on a drill. Here we have heading on the machine. We have the control box console here, and then we have an RTK position on top of the feeder. And then regardless of how the feeder is positioned, we're monitoring all of this data being fed back into the drill grade software. And again, we can either retrofit these sensors, or with the Atlas Copco FlexiRock and SmartRock, and with the HEC 3 protocol, we can use a cable, and simply Atlas Copco provides that information compatible with Carlson, and we can monitor it without having to retrofit. Here's a landfill compactor. I've got my control box, landfill grade software. Here's my RTK correction radio, and I've enabled the receiver inside the control box and place the RTK antenna on top of the roof of the machine, and then a pitch and roll sensor for the body to give us more accurate tracking. If I want to remove if I want to not enable the internal receiver inside the control box, I can use a heading unit, the all-in-one VX5 sensor, and that may also eliminate the body pitch and roll sensor and give me a two-component system. Same thing with a dozer. I could use the heading unit and get true heading, one cable to the CBX5, and then depending on the size of the machine, I may or may not need a body pitch and roll sensor. Or I could forego the all-in-one heading unit, all-in-one sensor, the VX5, enable the internal GPS plus GNSS receiver inside this box, add the antenna and the RTK radio. Or I could stream an RTK correction via the SIM card slot inside the CBX5 control box. I think for bulk earth moving and rough grading, this provides one of the simplest systems for scrapers. If I use my control box, enable the internal receiver, I run one cable to power, one cable to the antenna, and I can either stream the RTK correction via the SIM card slot or add the RTK radio. And I have a 3-year warranty on all of this. It's very powerful, simple, easy to install. If there's an issue with the system, fewer components with more integration make it very simple to troubleshoot. And here is an illustration for high accuracy material management in a haul truck. And we have a Truck Pro system software. That's the software. And all of this data feeds back to our central database via connectivity, whether it's SIM cards or mesh radio network, and all of this data is streamed back real time into a server on site or off site, anywhere there's an internet connection, and it ties all the machines together. It provides remote monitoring. You have a Fleet Explorer where you can set up your fleets, set up your different sites, and how you want to view and manage this data. The proximity warnings are reported in the data stream and viewed remotely back at the Fleet Manager system back in the office. From that data, we can produce productivity analysis and reports. We can have historical playback. Very valuable ways of measuring productivity, measuring efficiency, monitoring safety, knowing what's going on, where a machine is, Even simple things like perhaps a fuel truck wants to go fuel 30 machines, and perhaps they want to know which machine is lowest on fuel to go there first, and then be able to navigate to those machines. Very, very powerful feature set, and really it's unlimited to where this will continue to grow. So the office component of this is optional, but that's called Carlson's Fleet Manager Office with Heartbeat Protocol. That's what's connecting everything. And then separately productivity tools, which is doing a lot of the analysis and surface updates. I hope you found this helpful. If you have any questions, feel free to email me at rnoland, R-N-O-L-A-N-D, at carlsonsw.com, and we're happy to help you, and I'm happy to put you in touch with one of our dealers or have an OEM discussion. Thank you.